This is lesson 5 of chapter 10. So we're going to be discussing water today. This is the last lesson of chapter 10. So you guys should be getting started on your reviews. I think in the plans that I left, you might have 2 days for review. That'll, of course, depend on, how well everything else went and if you needed some extra time. But you should be getting ready to do that. So let's get started. It's a very short lesson. The homework for tonight, I think, is 1 page, just the front side. So let's get on with chapter 10, lesson 5, water. A lot of this should be at least somewhat review for you because we've talked about water before, some in chemistry and some in biology. So the structure of water is what allows it to have all of the physical properties and the physical properties that shows in all 3 phases as well. So water is a polar covalent molecule. We talked about those in about chapter 7. No, it was before that. I still can't remember what chapter that is. So polar covalent molecules, remember, means that here's the oxygen, and these 2 white structures are representing the hydrogen, and oxygen is much more electronegative than the hydrogen. So it means that it's going to attract the electrons in the bond more strongly. So each hydrogen becomes partially positive and each oxygen becomes partially negative. Okay, that also because of the way that these atoms are going to interact with each other once they're bound together creates a bent shape of water. So a lot of times we'll draw it kind of flipped over the other way and it will look a little bit like Mickey Mouse, okay? But these bonds are 105 degrees in between these 2 sides, okay? And so then 1 molecule of hydrogen can link to other molecules through hydrogen bonds. So when water is in the steam phase, right, the gas phase, it's not going to attract very strongly. Remember, kinetic molecular theory, gases basically don't attract one another. The gas particles won't attract one another because they're moving, they're so far away from each other, so they just don't stick to each other. But in the liquid phase, we can start to have these hydrogen bonds. So the hydrogen bond happens between the hydrogen of 1 molecule and the oxygen of a nearby molecule. Okay, and so as they form into the liquid phase, right, if we remove some of that heat energy and cool them way down, they'll start to condense into liquid water where you start to see these hydrogen bonds form. And so the hydrogen bonds, they can still move around each other, and those bonds are real weak, so they can evaporate. Of course, if they're at the surface, they can slide past each other. They can break the bond with 1 atom or 1 molecule and form a bond with another. Okay, so they are moving all over the place still. But when they form a solid, the water molecules form these hexagonal structures. Okay, so there's actually a lot more space in the middle than when there's a liquid. Okay, we're going to talk about that in just a second. But the solid state forms a very structured pattern. Okay, so let's go through the physical properties of water. We have talked about these before. A little bit kind of as we've gone through this chapter, we've brought it up. But we've also talked about it. It's a big part of biology. So at the beginning of biology, you discussed this. And you've probably talked about a lot of it before even that. Okay, so properties of water. First of all, water is the only substance that occurs naturally in all 3 physical states on Earth. It's the only one that can do that because of its boiling and melting points. All of the other substances, either their boiling or their melting point exists outside of a temperature that is generally found on the Earth. So this leads to some really kind of interesting things. So one, water has what we say, or what we call a very high specific heat capacity. And we're not going to talk much more about specific heat capacity. It is a topic that frequently gets covered in chemistry, but I don't think we're going to have time to get to it this year. What it means is that water can absorb a lot of energy, especially as heat, and not change temperature. So this is really important because, most of the earth is water. So it allows the oceans, to be kind of this reservoir of absorbing energy without the whole climate changing. Okay. So it takes a lot of, so it kind of it means that water gets to moderate our climate. Okay. So places that tend to be closer to water tend to be a little bit cooler. Okay. They also tend to have more like rain and stuff. So coastal areas tend to have like a warmer winter and a cooler summer than if you were to go further inland. So we are just close enough to the coast that we get that effect. If you go from here and you drive due west, you pretty quickly start to see the vegetation get pretty sparse, and it doesn't take very long before you're like, this is a desert, right? Okay, because they're further from the Gulf of Mexico. They don't have that water source. So this lets so high specific heat capacity means the oceans can absorb a lot of energy or have these great energy or temperature changes without the ocean freezing and without the ocean starting to boil. Okay, it's important because things live in the ocean. So another property of water is that ice is less dense than the liquid water. I'm going to go back to the slide to show you why. And it's this crystal structure that it forms with this gap in the middle. It's less dense than the liquid state. What does it mean for the solid to be less dense? I hope you're getting to it floats. Okay, why is it important that ice would float? Well, because again, stuff lives in the water. So what happens is that the top part of the water freezes and the rest of it tends to stay liquid. So the stuff that's living in that lake, ocean, whatever, doesn't die, generally. Okay, at least not by freezing. Okay, so it creates kind of an insulation layer, actually, is what happens. Water has a very important role in that it can dissolve a lot of things. So in biology, we call it a universal solvent. It dissolves lots of stuff. So that's important for moving materials, transport your blood, right? You have to have a lot of water in your blood so that you can move your blood cells around and carry oxygen. It's also moving wastes. So it's moving the carbon dioxide away from your cells. It's moving the ammonia away from your cells, so that you can create urea and then get rid of that. Okay, so water is really important to all living things, not just because it helps us to, maintain a pretty constant temperature around the world, and because it is less dense as a solid than a liquid, which is unique to water. But also it dissolves stuff, dissolves lots of things, so it keeps the internal environment of lots of different organisms within homeostasis. I'm bringing some biology terms here. But it's also really important for a lot of biological reactions. Most of the reactions that occur in your body require water. So they either have to have just a watery environment to even occur, or they actually directly use the water, like photosynthesis and respiration. Okay, so photosynthesis, the plants have to have water in order to turn carbon dioxide into sugars. Okay, so water is extremely important in both biological and chemical reactions. So the chemical reactions would be like photosynthesis and cellular respiration would be examples, but there are several other, there's just tons of other chemical reactions that happen in your body that require water. Okay. And then there's a lot of other properties, or sorry, a lot of other reactions as well that are not necessarily biological reactions, but just chemical reactions that have to have water. So you can look in your book and see other examples of how water plays a role in biological systems and in chemical systems. Okay, and those that I think comes up on your homework, so you might want to look that over a little bit. Okay, it brings up like electrolytes and stuff, which we'll talk about again, I believe in chapter 12. Okay, so this is not a long lesson, it's actually the end of the lesson. So you need to start working on your reviews if you haven't already, and since I've been teaching you all year and for many years, I know you haven't started them. So you want to get started on that, and good luck on your test. As always, message me with questions. I'll get back to you as soon as I can. And I don't know, look forward to hearing from you, at least maybe somewhat.